Assalamu alaikum. So today we have element 11. So I'm just waiting for my students. So we'll inshallah start at 10 o'clock Saudi Arabian time and 12 o'clock Pakistani time. So stay tuned, inshallah. We'll be starting our class right after 15 minutes, inshallah. Because since I shared with you a lot of incidents as per OSHA, and several reasons they found because of overhead power lines, sometime working with electrical panels, and plenty of incidents happened, like having some maintenance with the generators or other underground power lines even. And several incidents happened just to work with the junction boxes. That's why it's important to understand what are the key hazards associated with electricity. Skipping this lockout tag outs, I totally agree, because sometimes people believe if I will shut off the system, or nobody would like me, so it's a very small task. So what can't I do, since I have 20 years experience or 15 years experience, so nothing would happen to me. So the problem is, with this mindset, the problem is we can't be lucky forever. I mean, ignoring. And on the other side, for easy understanding, if we are breaking, if our employees are violating or breaking any kind of safety rule, basically it's an unsafe act. An unsafe act means more probability, more chances of incidents or accidents, that we are welcoming the terrible accidents. And if electricity is involved, that means the terrible power will destroy immediately if someone have live contact, or maybe due to any, sometimes the radiation is there, like magnet. If you are like working under live cables or overhead power lines, and the voltage are maybe more than 250,000. So just imagine, if you will ignore the safe distance, even like magnet, you will be caught up, God forbid. And this is how things could be out of our control. That is why we have to understand what key hazards are there. And even though this lockout tag out, they know how to use it, they know how to lock, they know how to tag, but that is the most neglected area. Again, I would mention, especially in manufacturing industry, because they don't want to stop other machines. And even though sometimes they have separate breaker, but still the whole panel they are not willing to close. And that is why it's very much terrible challenge, especially in manufacturing industries. And in construction industry, they always have a mindset, oh, it's not a problem for us, we can go in any way, short temporary solutions. You will see a lot of violations, especially in construction industry. So yes, I totally agree with Mr. Muhammad Al Ghamdi, mashallah. The way you mentioned, like forgetting PPs also, not forgetting, basically, yes, at some level you can say unintentionally, if they are not using the PPs, or the company couldn't provide them, then definitely it's an excuse. But otherwise, if you are going to work with live cables or kind of panels, even lockout tagout is done, still PPs are a great protection. And yes, improper grounding and damage extension cords is another reason. So what kind of hazards are there? Still, question is still there. Do you think we're gonna get fire hazard from electricity, or arc flash, arc blast, or burns, just because of electricity or electric shock? So if those hazards are there, what should be the best controls? How we should control electrical hazard? That is our next question. how we will control electrical hazards. How will we control electrical hazards? And we're talking about our understanding. Later on, we'll learn something from Nebosh theory for sure. Because the purpose of control is we don't want to see any incident because of electricity. Even though 100% safety still is a big question mark, because several minds are involved. It's not like it's not a one-man show, by the way, because everybody have to be responsible in that context. Like if Mr. Muhammad Al Ghamdi mentioned, this if extension is overloaded, it's a terrible mindset. Might be in residential compounds in one room, you have 4 or 5 or 6 employees living together, and then definitely they'll be violating. I mean, might be one extension board is there, and everybody have laptop and maybe mobiles or even iron, to press their clothes. So several things are involved, and only one extension board, which was basically designed for 2 persons or maybe for 3 persons maximum. But now if you are living like 5 or 6, itself is a big hazard. And because of COVID-19, even that suffocated environment is not recommended. Now let me see how you will control electrical hazards. Like if you mention forgetting PPs is a hazard, then how are you going to control it? Like if you have 500 employees and out of 500 you have 50 electrical engineers, how are you going to make sure they'll never forget PPs before working? You'll motivate them, you'll have a training session, or or one-to-one counseling or on-site visit, and every day a reminder for them, don't forget to your PPs, or you'll just rely on inspection and monitoring. Same way, if damage extension codes are there, what would be your best control? Either you're going to have someone every day just visiting and doing inspection only for electrical systems, and then coming back with a lot of stories if something need to be improved every day. And electricity, sometime directly the word tick in our mind is the power. And if that power is uncontrolled, drastic, terrible consequences. Controlled electricity, we all are using, even, right now we are using, but it's controlled one. We have, right set of wires, extension boards, and we have understanding also how to keep ourselves safe, and no damaged wire, no broken switches. And we understand also the power of electrons because of this electricity, how that power can boom up and kill a person in seconds sometimes. So for whenever I ask the word control, that means the hierarchy of control should come to our mind, like elimination, substitution, administrative control, engineering control, as well as the PPs. Whenever you are going to control any hazard, hierarchy of control must be followed, must be respected and followed, I would say. Because sometimes we don't respect. Oh, this control is very much expensive, so we can't give any respect to that control. But later on, be ready to face the accident, God forbid. That is why some companies, they have open budget for safety, but they have only one goal, 0% accident, zero accident club they try to create and they have a straightforward, KPI, understanding and agreement with the safety teams also. Whatever you need, just let us know. Logically, technically, it must be correct. And we are ready to provide all the resources. And now you are responsible. We'll provide you all the authorities and also required sources, resources, in other words. That means now you become accountable. So there are several brands, they have open budget for safety, but they don't want to see any accident or incident. Still, it's a big question mark. Now let's talk about Nebosh theories, what they are guiding us, the key learning objectives. As mentioned earlier, the hazards and the risks associated with the use of electricity, especially in the workplace actually. And ultimately, we'll discuss how to control, what kind of control measures can be there, especially working with electrical systems or using electrical equipment in all workplace conditions. So very straightforward learning objectives. Now let's talk about the hazards and the risk of electricity. Even though we have enlisted some of the hazards, but let's see how Nebosh is guiding us. First of all, let's have some understanding what is electricity, like introduction of electricity. An electrical circuit has three parameters. One is the voltage. That means our potential difference measured in volts, or we have current, which is going to be measured in amperes, and we have a resistance, would be measured in ohm. That means the link together by Ohm's law, V is equal to I multiply R. So voltage, if you want to find out, I must be multiplied with resistance, means current will be multiplied with resistance, and we're going to get the voltage as per Ohm's law. And no doubt we have direct or indirect two type of electricities. So we will discuss later on that one also. So vice versa, through different triangles, we can create three formulas. If you want to know about the voltage, we will multiply I with R. And if you want to find R, we will divide voltage over R. And if you want to find R is equal to V over I. And note the current is given the symbol I. So if you know the values of two of the elements, you can calculate the third one. So this formula can give you an understanding, like if you have some kind of electrical systems in place, so you can ask your electrical engineer, can you give me, some of the actual voltage every day, they are evaluating that volts are not going up and down, and if they are going up and down, what is the average and how they are calculating the number of amperes or the resistance as well. Now, since I discussed, we have AC and we have DC. That means alternating current or direct current. Direct current, even the word is very pretty straightforward, like battery supply in DC. Current flows in one direction only. But in alternating current like AC, which main supply is AC, but voltage alternates from plus V to IV and back again. Therefore, current flows backward and forwards, like in UK 230 volts 50 hertz, or in US 120 volts so 60 hertz. Like if you take some examples, of power tools, the first single most important element is this power tool is for how many volts, like it will run on 110 volts or 220, designed for 110 or 220. And if it is 110, Either my electrical installations, my switches and all, the whole system will be supporting 110. Or if I have 110 system and buying 220, that is why, in Saudi Aramco now they have standardized 220 only, everywhere. So 110 is not recommended. No, the hazards and the risk of electricity, like electrical shock gonna be there, burns, fire and explosion, arcing and secondary effects as well. So these are the key hazards: electrical shock, burns, fires and explosion, arcing and secondary effects. Now how are we gonna control them? But before that, we have to understand the effects, of short circuit. Like if the current milliampere flowing through the body, like 0.52 up to 2, that means the threshold of sensation, that means still effect is there, and 2 to 10 milliampere, tingling or sensation or muscle tremor or painful sensations would be felt, and those are the effects. 10 to 60 milliamperes, muscle contractions, inability to let go, inability to breathe even. That means the breathing system would also be affected. Now, if it is like 60 and above, ventricular fibrillation or cardiac arrest or extreme muscle contractions, burn at contact with points and deep tissues, That means we can consider, kind of ideal edge, same like we have for others, like, immediately dangerous to life or health, like 60 or above, and even 10 to 60 also have terrible effects, like muscle contractions or inability to let go or inability to breathing even. Now, another point is the severity of shock, of course, influenced by either voltage, duration, current bar, resistance, and contact surface area and environmental factors, clothing and footwear, and frequency. So these are several, kind of severity of shock is influenced, kind of influences actually. Like if we talk about voltage, the higher the voltage, the greater the current. Quite logical. And exposure time, if someone is electrocuted for 1 second and the other one is electrocuted for 20 seconds, so because of duration, the effects would be terrible accordingly. And current path routes through the body and resistance is skin condition or clothing. Like if wet clothing is there, so more terrible consequences. If skin condition, like if it's wet, or if the person is like, or the aged person, if the skin is very weak, or so that means it depends, like the child, the teenager, the young person, and also the aged. So accordingly, the skin condition would be, someone have strong skin, so maybe more resistance, but if it's the weak one, more terrible consequences. So the contact with the surface area mean more skin contact, more severe injury. There are, of course, environmental factors like metal surfaces, humidity, etc. Clothing and footwear affect resistance blocks, reduces current flow as well. And frequency means the AC alternating current more harmful than DC at the same shock current. So AC is more harmful, and normally we all are using AC at our home, within our companies. Now, somewhat we are trying to have solar system, but still we are creating solar, some energy through DC, but again converting into AC, to run our systems actually. So let's talk about electrical burns. No, direct electrical burns means current flowing through the body. There are entry and exit points, and internal tissues burns actually. And this is called direct electrical burns. That means the current flowing through the body, entry and exit point, and internal tissues burn. So it just passed through and went outside, but the tissues are burned internally. Like we say, internal bleeding is very much dangerous. Same way, internal tissue burns, of course, not good, for human health. Even the person is survived, still it's not good for him. Indirect electrical burns, an electrical accident causing something to overheat or explode, like arc flash. Several incidents are happened. If you go back like 100 years history of electrical accidents, you will see a lot of incidents of arc flash and arc blast also. And the reason might be the loose wires, in the panel board and the breakers, and sometimes maybe poor housekeeping, and sometimes the person, he couldn't make sure the proper lockout tagger, and sometimes the miscommunication. Oh, one breaker is out of order, so I can't stop the machine. I changed the wire and placed to another breaker, but didn't communicate with my team. And even didn't updated the drawing layout, of our electrical systems. But only that person, gentleman knows, that he has changed the wires from one breaker to another. So this kind of miscommunication or no communication or lack of communication, in other words, also causing a lot of incidents. That is why we have shift rotation meeting, kind of like if I'm working in day shift, I'm in charge of day shift, and you are then in charge of night shift. I'll definitely hand over and share all the stories of the day. I'll share everything, whatever small changes we have applied throughout the day. I will update. We'll update even any abnormalities or kind of challenges or any incident, God forbid. We'll share with them so that they would be more capable to handle night shift. But imagine if we don't communicate or if we hide some issues, even the night shift would be in trouble. Now, what are the causes of electrical fires and explosions? The number one, we all know, the faulty electrical equipment like overheating. And then, let me give you one example. Since I have 3 years diploma for electrical systems also, so I try my level best, to resolve all sort of electrical issues, if any there within my home. I must be corrected by myself. Now, our electric motor is suddenly just stopped, and definitely without motor, how are you going to get water from the ground? Normally, we get water from the ground. The clean water is underground. The more deeper you go, the more better clean water you're going to get. And motor suddenly, and there was warranty and guarantee also, and I just realized how come it could happen. But because we gonna have separate breaker which can trip if there is any issue for all the rooms separately, for all the heavy equipments, electrical appliances, separate breaker for everyone. And even for motor, luckily we have separate breaker in the panel board. So I realized it's not like the total burnout, might be a capacitor, might be some loose wires. So let me check, So I just took the tester and make sure. And I was right, the The breaker basically kept it safe, the motor, and only the capacitor was burned out. And I just brought the new one and changed it up. But that capacitor still I'm worrying about. How come it could be overheated? Either we got more voltage, even we have in the panel board, some voltmeters. So, but we are not having the camera or study all the time, what are the volts actually at that time. But definitely there were some fluctuation up and down, and that affected the motor. But the whole pressure couldn't be bear by the capacitor, so it burned out and started giving some smoke as well. So overheating system is not like only the panel boards or only the some power tools. The overheating could be anything, even at your home. Like even you are using iron for pressing your cloth, and voltage up and down still could affect or the wires or the iron could be overheated and immediately. So you never know how that overheating could be affecting because of so many, and it's really hard to avoid the fluctuations of voltage. Like if your company, take an example, if you're getting electricity from Sekiko or SEC, in other words, I mean, go and double check at your transformers, 3-phase or single phase, whatever. What are the voltage level, how they are fluctuating, and then what is your need internally, like how many machines you have, ACs you have, several electrical appliances. Now measure your internal systems, like you required, let's take an example of 1000 amperes, let's take an example, but the transformer is giving 900 or 950. So your system would be in trouble. Sometimes something is being tripping, right? Now take another example. If your requirement is 1000 amperes and transformer is giving 1100 amperes, that means your need is easily being fulfilled, but still you are facing some fluctuation. Then surely your electrical system, your wires, the way you installed everything is a great question mark. Maybe some wires, they are losing some amperes even on the way actually. Or maybe some machines are miscalculated. So sometimes that is why we have separate third-party survey only for our electrical systems, to know about all the variables and understanding with that concept that nothing will go wrong because we are managing even this fluctuation. Because any overloaded system, a terrible fire hazard, because of explosion or because of your fire, because of this electrical overloaded system. And plenty of overheating we're gonna face, especially during charging. Normally for forklifts and for several things, we just put them on charging and the whole night is on charging, because we believe it would take 8 hours or 12 hours and then gonna be fully charged. And without that calculation that we didn't use this forklift routinely, if we are using for 6 hours or for 8 hours, then full battery we need to charge. But if it is just used for 2 or 3 hours and you still believe throughout the night it has to be put on charging, and your employees don't expect they are the right mindset or kind of trained mindset like you, they're just ordinary employees. Don't expect they can think like you or like a scientist. What can go wrong? Same way, equipment may be misused also. Flammable atmosphere with wrong type of equipment and accidentally created as well. And most importantly, the electrical equipment producing heat or spark in the normal use. That's another, sometimes equipment itself is creating a lot of heat and sparks, and that could be causing fire and explosion. Now, poor internal electrical connections and normally whenever we have this consulting project for any company, we take electrical systems risk assessment entirely a separate document instead of just pushing in the risk assessment register and the job is done. We take it like a separate industry, to be very honest, and we measure each and every element within that risk assessment, and we don't do it, we just facilitate, we utilize their electrical engineers, their electricians, or their electrical maintenance teams. Even they are the one who have to do risk assessment, and we'll be just reviewing and supporting, if something we need to add or delete or amend as per the standard. Otherwise, they are the one going to do it. And through this risk assessment only for electrical systems, they will find a lot of abnormalities in advance, and that's called proactive approach also. Now, there is another type, the static electricity is another hazard. It could be built up of potential difference like volts or between surfaces. It is sometimes caused by friction. Just a small example. If I will rub this pencil to my hair, and now if I want to, a little bit extra, and now I want to lift something like small particles from the ground, it will catch for sure, because this friction created some static kind of electricity, or static charge. I hope now you got the point. So wherever things are rubbing together, they are also creating some static electricity. That is why, even for this oil tanks filling or storage tanks, or even, from the refinery to up to the petrol stations, if you're bringing that oil in different containers or different tanks, why we do bonding, why we do, earthing, why we go for this one? Because we don't want to see any fire incident because of static electricity, because the moment liquid will hit to the ground and the height is so much, and if it is hit directly, so this friction, like hitting to each other, this terrible friction definitely would create some static electricity, which is enough to create an explosion and sometimes a terrible fire incident. And everybody gonna be shocked what happened. That is why we have earthing, bonding, and and just to make sure how we gonna avoid from this static electricity. Now, surfaces become charged, like I gave you an example, and static shock, very short duration, static spark, and spark caused on contact with earth. Let me give you one more example. Imagine there is an incident because of overhead power lines. The crane operator just opened the boom and it's touched to or the hook is touched to the overhead power lines. Now, electricity find another way. It will be passing through all the metal parts of the crane, even to the ground. So now, how much ground level in circle would have electrical or kind of static electricity, because the whole ground maybe up to 10 meters. Now, if the crane operator coming down immediately and putting his foot or walk like this, it's all over. Because the moment he's like taking footstep like this, that means the electricity found another way, like passing through his body, God forbid, and it's over. Because the whole area was fully charged actually because of this electricity overhead short circuit. I hope you got the point. So it's not like only the crane itself, even the nearby area also got electricity. Now, whoever will be stepping up and down is giving another way, passing through his own body. So what is the best way? To keep your feet along with the floor and just walk like this, But no up and down. Just you need to rub through the land or through the surface up to 10 meters, or even might be more than that, because it depends on the voltage level or kind of amperes, And sometimes the spark, very short duration static spark, or spark cause on contact with air, and risk of igniting flammable liquids. This is another one. No, one more hazard, the arcing. It is kind of ability of electricity to jump across the air gap. Usually involves high voltage, overhead power lines. What are the main hazards? Electric shock, direct burns from the arc, indirect burns from the radiant heat, and damage to eyes from UV light. Because arcing means a sudden unbearable light, directly. Like if our welder, let's take an example of our welders. Imagine if they don't have face shield or no goggles, and they're welding. Within no time, they'll be just losing their eyes because of this just radiations from the welding process. Same way, the damage to eyes from UV light. What secondary effects gonna be there? The physical injury caused by an electrical incident, like falling off a ladder, causing like cuts, bruises, and broken bones. These are secondary effects. No, some of the dangerous activities, use of poorly maintained electrical equipment. And personally, as a safety auditor, what I have noticed, sometimes the electrical equipment is depreciated, is expired, and the shelf life is over, but still they are using. Still they are using. What they believe is, oh, nothing would happen, Like if the shelf life of an electrical equipment is over, take an example of, forget about equipment, take an example of breaker, take an example of your electrical wire. If it is designed for 10 years and you are using it for the last 15 years, the probability gone up of any, kind of a short circuit, and because of that short circuit, mostly the fire incidents are happening. Why? Because we compromise with the shelf life, because the quality of that wire was designed for 10 years and you are using it for the last 15 years. Same way, the electrical equipment, the shelf life is critically important. That is why, some companies, they call us as a consultant only for assets management system, nothing else. We will just be establishing and, guiding them and making procedures only for assets management as per ISO international standards. And some companies, they have separate management system only for electrical. Again, ISO standards, the benchmark, and they also achieve certification like 50,001 or something like that. Only for electrical systems to be certified, established, and to be certified through third party. Same like we have for quality management, we have environmental management, we have occupational health and safety. So same way we have international management system for electrical, the system management system for only electrical or kind of electricity, within the companies. So it's very much, important subject, the use of poorly maintained. That means we have to maintain the electrical equipment. Imagine you purchase an electrical equipment and it is designed for 2 years, that after 2 years, you have to bring the new one. But you purchase it for 2 years, but because it is not well maintained by the user, by the end user, no maintenance, no proper cleaning, every day just using and using. Now the shelf life is not 2 years. Because of his poor behavior, because of poor maintainability, the shelf life gone down. I hope you got the point. So like you purchased a new GMC or Lexus car, and it designed for next 20 years or 50 years. But because of your rush driving or terrible driving, within 1 year, even nobody can recognize this is a new car, or because you just demolish it within 1 year. So it's not the same shelf life. So the behavior of the end user is critically important to maintain, and that is why the role of maintenance team, especially to follow preventive maintenance plans, which are more neglected, especially in developing companies, I would say. Same way, the use of electrical equipment in wet environments, a terrible hazard indeed. Use of electrical equipment in wet environments, work near overhead power lines. Now here, just I can open up one discussion, like work near overhead power lines. What should be the safest distance if the volts are below 50,000 volts? What should be the minimum distance? Like we are doing some excavation, we are doing some scaffolding, we are doing some rigging and lifting. So how far we have to be from overhead power lines? I'm opening this question in the chat box and let's see who can respond to it. Distance from overhead power lines, like below 50,000 kV. kV means 1 kV, 1 kilovolts is equal to 1000 volts. So 50 kV, that means 50 kilovolts means 50,000 volts. Or if it is above 50, kV up to 250 kV, then what should be the distance? And even if it is above than 250 kV, then what should be the distance? So distance from overhead power lines, if it is like 0 to 50,000 volts, means below 50,000 kV, 50 kV or 50,000 volts, or it is like 50,000 to 250,000 volts, or 50 kV to 250 kV, in other words. Or if it is like above than even 250, what should be the safest distance, from the overhead power lines? Even the underground power lines. Because it's very much important to understand, work near overhead power lines. And don't expect that every time you'll get permit and close, the lines and they will create a safe haven for you. It's not. There is a big fight I personally noted between Saudi Aramco and Saudi Electricity, just for this one segment. Saudi electricity saying, no, no, we can't stop electricity because otherwise the whole area would be in trouble. Aramco is asking, no, no, within our area, you have to provide the permit. Or sometime, if you are working like Saudi electricity teams, if they are working near even Saudi Aramco territory, the Saudi Aramco, they will enforce their policies. Where is the permit? And Saudi electricity teams, sometimes they have no idea, because Aramco means again a big brand and a lot of, the huge territorial project-oriented lands are there. And sometimes we don't have drawings of like the full layout of Saudi Aramco areas. And even those drawings are available with Saudi Aramco, don't expect they will share with everyone. So what I mean is this clash was there, and when I was giving training to Saudi electricity, like consultants and all, and some engineers, they also shared the same issue, they're facing with Saudi Aramco. Because whenever they are going to do anything near to the even pipelines of Saudi Aramco, they ask, where is your permit, Mr. Electricity? We need the permit. So that is why I generated this question. What should be the safest distance if 0 to 50,000 volts are there, or 50,000 to 250,000 volts, or 250,000 to above? What should be the safest distance from overhead power lines? Even take an example of underground power lines. Take your time, and I'm expecting something because now it's open book, so you can search, you can find out your answer, but let's see how you respond to it. Okay, so what I have done so far, even though I can just speak up, like what is the distance and all, but the key point is we have to be like, get some reference of standards. So if you will see your WhatsApp group, I'm sharing, some of the things only related to overhead power lines. And one of the kind of a snapshot or screenshot, like if it is up to 250,000 volts, as per OSHA, minimum 3 meter or kind of 10 feet distance must be there. And if it is like 50,000 volts to 200,000 volts, then 15 feet distance must be there. Same way, if 350 to 500, the more the voltage, the more the distance you required. So I shared one from OSHA and also from UK, one screenshot I also can share. Like from UK, low voltage line, minimum 1 meter. And if it is like 11 kV and 33 kV lines, then 3 meter minimum as per HSC UK. And if it is like 132 kV line, then 6 meter, and 250 kV up to 400 kV lines, 7 meter. So I'm sharing this one also in the group, because the key point is even in our risk assessment project, if we are completing, we surely have to give some reference why we are claiming, oh, this is the best solution or control against that hazard. And we can give ultimately some references, because as per this theory, this is the best solution for against that particular hazard. Same way for IG1, also we required, no doubt, it's an open book. We have, clear understanding how to browse, how to find out the answers, but still without reference, those answers will not be entertained with better marks. That is why I gave this opportunity, whenever like overhead power line, just find all the standards from UK, from USA, from your even Royal Commission. Find out what they are talking about whenever we are working near overhead power lines. Now, contact with underground power cables, again, some rules which I shared already, some standards. Contact with underground power cables and work on mains electricity supplies. Now, we have one more topic here, the fixed and portable electrical equipment, like conditions and practices likely to lead to accidents, might be the unsuitable equipment, using equipment in damp conditions or misuse, physical abuse as well, improper repairs or taped up joint, that means temporary solutions, use of faulty or defective equipment, chemical calibration damage to the flags, and lack of inspection, testing, or maintenance. So these are some of the issues related to fixed and portable electrical equipments. But the last one, lack of inspection, testing, or maintenance. As per my understanding, inspection sometimes is the most neglected area, because we don't want to be proactive, even though we have inspection checklist for everything. But normally the practice as a safety auditor, I observe mostly that tick, 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 that everything is okay. But of course, your company is like a role model. I'm sure you guys would have it in very much detailed manner and will be taking every small element, even at the checklist, and focusing and making sure it is done, and then you are ticking. This is all okay. Now 11.2 is all about control measures. Look at the picture first. The real challenge is protection of conductors. How are we gonna protect the conductors? So one way around is insulated to prevent contact with live conductor, cables covering unbroken, and equipment casing intact. Inspect to ensure protection is in place and ensure electrical panels are locked. So we truly have to protect the conductors. Now, ensure electrical panels are locked. In one of the company, they were having more than, almost 50 machines, and each machines have an electrical panel directly attached with the machine on spot. Even though those panel getting the line from the main panel boards, but still the sub panels are there along with the machine. And the moment I was doing the safety audit of that company, the moment we opened few of the locks, even they were locked, by the way, the panels were locked, and we requested the employees, can you open that panel? And we found what? A lot of eatable things, a lot of cloth inside. I'm sharing practical examples. I mean, they were using that panel board like a locker room, like a locker, that they can put their personal belongings, because he is the machine operator, having one helper also, and mostly putting several things inside the electrical panel. And they have no idea you are giving more fuel to the panel. That means more chances of fire incident, and also a very terrible bad practice. And also one more important point I noticed, there wasn't any rubber mat right in front of the panel. Like if you are a maintenance technician and going to work for any panel, there isn't any rubber mat. That means no protection. So any direct contact, if you don't have better safety shoes or with the special resistance to electricity, then of course anything can happen. And several panel incident I noted from the history was just happened because of the panels were not having good ventilation, and mostly getting overheated, and sometimes the breakers are burned out because of electrical fluctuations. And the terrible bad practice, the employees have no understanding that they should never keep anything, especially their personal belongings, inside the panel. So from that day, to be very honest, I realized expect the unexpected. Expect the unexpected. That means you never know whoever employee can go in which direction. Yes, we required strength and capability of equipment. That means the electrical equipment must be carefully selected to ensure that it is suitable for the electrical system that it will become a part of, task that it will perform, and environment in which it will be used. It's not like immediately just buying the equipment and your existing system probably not going to support. So make sure whatever you are buying, it is adjustable within your existing electrical system, within your company. No electrical equipment should be put into use where its electrical strength and capability may be exceeded. No electrical equipment should be put into use where its electrical strength and capability may be exceeded. Now, what we have to consider to ensure the strength and capability of equipment, the number one is the weather. The natural hazards like gnawing by rats and even, extremes of temperature and pressure, like heat from motors, dirty conditions like corrosive conditions, and liquid and vapors, that means splashing, flammable substances, and foreseeable mechanical damage. So the equipment strength and capability, these factors have to be considered. Like for weather, how it would be like behaving in the terrible weather, and how he gonna resist the natural hazards or extremes of temperature and pressure, or heat from motors, or dirty conditions, or corrosive conditions, or liquid and vapors and splashing, and also flammable substances, foreseeable mechanical damage as well. So any equipment, we have to double check their strength and capability by considering these factors. Now, of course, we are talking about the controls against electrical hazards. So we truly have to make sure we have protective systems and devices in place, especially like fuses and magnitude like circuit breakers. We required earthing. We need isolation of supply. We need double insulation and also residual current devices. But residual current devices, if let's take an example of your power tools, electrical power tools. That means the 220 always required RCDs, residual current devices. But if you are using 110, then even GFCI will be working there. Ground for circuit interrupters. But if it is like 220, then residual current devices is mandatory to protect system and devices and reduce and low voltage systems as well. Now we have a group exercise. Consider 2 appliances in your home with different protection methods. Explain how each works and the advantages and limitations, like an earthen washing machine, RCD an electrical mower, or fuse on a small lamp, or double insulation on a laptop transformer, or circuit breaker on main electricity board. So any of the 2 appliances in your home with different protection methods, and you just need to explain how each works and the advantages and limitations, like an earthed washing machine or RCD residual current device, an electrical mower or fuse on a small lamp, double insulation on laptop transformer or circuit breaker on main electricity board. So consider the moment you'll go back at your home, just remember that question and have some understanding, what are the advantages and limitations of any of your two appliances, at your home. Now, fuses and manufacture like, the circuit breakers. We have fuses, prevents current overload. It will be helping because it will prevent current of overload. Whenever there is an overload, of course, the fuse would break the chain of the electricity. So automatically you will have an idea to change the fuse and just protect. And it's a protection from overcurrent actually. And also the weak link in a circuit and overheat and melts if the current exceeds the fuse rating. Designed to protect equipment, not people, by the way. And of course, there are some advantages and disadvantages of fuses, which you can search and find out in a better way. Now, miniature circuit breakers similar to a fuse but prevents current overload. That means an overcurrent protection device. Also, electromechanical device. Trips a switch, can be reset, tamper-proof, and also designed to protect equipment. But most importantly, again, not people. It will be protecting equipment, but not people. That is why there are advantages and disadvantages of miniature, circuit breakers or even fuses. Can we just find out the advantages and disadvantages of fuses? Let's complete this exercise, Advantages and disadvantages of fuses. Just as a practice, let's see how you respond to it. Advantages and disadvantages of fuses. Like one of the advantage, of course, is already mentioned in the presentation also, because it will break the circuit and it will help, whenever there is overcurrent, So that means it will be protecting electrical devices against overloads or short circuits even, And another advantage, because they're very cheap in cost, that means not expensive. And whenever a fuse burned out, so immediately we change and the job is done. That means the kind of very less time actually required to complete the circuit again. But what are the disadvantages? Because fuses, can we rely on the fuses only, or it is the best way to protect? because of course it's also have low breaking capacity and like which one is more important, the circuit breakers or the fuses? Of course we'll go with the circuit breakers, right? But yes, for fuses still being used in several domains of electrical systems, but more importantly now the breakers are giving better protection even. So these are some of the limitations or kind of disadvantages. And yes, Mr. Abdulaziz, fuse is slow compared to circuit breakers, of course, Now, can we find out some of the advantages and disadvantages of miniature circuit breakers? Miniature circuit breakers. And sometime, this miniature circuit breakers, you'll find the word MCBs, the kind of abbreviations actually. Even though it's an electromechanical device. And the key benefit, advantage, same like fuses, but a little bit better than fuse, of course, it would also be helping from an overcurrent. And most importantly, whenever the fuse is burned, we have to change. But whenever the MCBs are tripping out, we don't need to change them. We just need to turn on, after making sure the things are in the right direction. So, and also bear in mind, everything have some advantages and also disadvantages. Everything. Like same like fuses, it's also have some slow tripping and also aging and wear, and it is also vulnerable to the heat as well. And on the other side, they are more expensive than the fuses switches. And most importantly, bear in mind these MCBs or miniature circuit breakers, they are not a good protection against, kind of we call, this earth faults actually. They don't protect against earth faults. So in that context, everything have advantages and disadvantages. Let's see what are the advantages and disadvantages of earthing. Like an event of a fault provides a safe path to earth, outer metal casing connected to the earth by wire. Electric shock should be minor. And of course, there are advantages and disadvantages of earthing. Can you please mention advantages and disadvantages of earthing? Advantages and disadvantages of earthing. Because if you remember, the fuses, they protect equipment, but not people. Even the MCPs, like miniature circuit breakers, they also mostly protect the equipment, and also some level to the people as well. Because if the circuit is broken up and if someone is working, still is kept safe. But most importantly, this earthing, the biggest advantage, it keeps people safe by preventing electric shocks actually. And also it also helps to prevent damage to the electrical appliances or devices, especially like excessive current or kind of overcurrent, which can be running through the circuit. And as I mentioned, everything have advantages and disadvantages. So now, what is the disadvantage of earthing? And now we are getting three words here, like the earthing, grounding, and bonding. I repeat again: earthing, grounding, and bonding. But right now we are just talking about earthing, not bonding, not even grounding actually. So guys, waiting for your answer, and after that you can go for lunch and prayer break. Just share some advantages and disadvantages of earthing. Yes, Mr. Abdulaziz, it will add cost, but there are some other disadvantages. Because there is the possibility of high over voltage, which can be occur between all live parts or between live parts and p conductors as well. And also it can create some over voltage stress on equipment insulation of the installation as well. And if the earthing is not done, or it is done in a bad way, then of course it can cause lights in especially the company to dim, or to that means it will not run the way it should be. We have to be careful about the disadvantages. So the installation is critically important here. Even though earthing is a safe circuit, and even like in my home in Pakistan, even to keep my home safe from sky electricity, I have done earthing, one wire directly from the top roof of my house and putting into the ground. So even the sky electricity, if that impact gonna be there, God forbid, I gave the way directly to the earth, not to impact the house, God forbid. So there are plenty of advantages, but yes, if that wire is not good quality or the system is not installed the way it should be, of course, it will mess up sometime. So that means we must use the best type of earthing. And of course, the moment we talk about best type of, like you, Mr. Abdulaziz, you mentioned the cost. So the quality is, of course, is expensive. So like plate earthing, if you're gonna use, is the best earthing, but it's expensive. Excellent, Mr. Abdulaziz. You're absolutely right. Not recommended with unstable soils. Yes. Okay, guys. Thank you very much for your great patience and focus and energy. So go and enjoy your lunch and prayer break. And I'll catch you back at 1 o'clock. In the meantime, if you believe there can be some chit chat or discussion about standards, or I shared some of the documents in the chat or in the group, the WhatsApp group. So you just can have a look into it for 5-10 minutes if you get during your lunch and prayer break, and then we'll start at 1 again, inshallah. Thank you very much. Take care of yourself. Assalamu alaikum, everyone. Welcome back after a lunch and prayer break. So our element number 10, we are discussing about electricity. Sorry, element number 11. So it's all about the new topic, the isolation of supply, the lockout, tag out. And look at the picture first. And I'm sure it's quite routine things you're going to be see through your maintenance teams, and either the technical maintenance teams or maybe from electrical or some others even. So the purpose is quite simple: to remove electrical power from the circuit or from the system. And why we do it? Because we don't want to see any fatalities or any kind of accident or even major injuries, especially for our employees working in isolated areas, or especially for maintenance or repair projects. And yes, of course, we have switch or isolator or removing the plug and circuit dead or safe to work on, and physically secured by lockout and tag out. And sometimes if we just put lock and no tag, or sometimes we just put tag and no lock, it's not acceptable. The moment you have lock, so make sure the tag is also there so people could be fully familiar, not to touch, not to come into that area. And most importantly, should be clearly labeled. That means we call it kind of a visual management. The itself the log should be highlighting there is a danger zone, so nobody should touch, nobody even come to that area. That is why it is important to clearly labeled, and circuit should be tested also. It's not like just putting your lock and tag. Even it must be verified First of all, from your side, and even someone else, must be there who will just double check that the lockout tagout process is fully followed, and there isn't chance of restarting of that equipment or machine or area or panel or even the switch itself. And yes, there are some advantages and disadvantages of isolation of supply. Sometimes we believe it's the most reliable one. Sometimes we believe, no, it's not reliable, because anybody can open the lock if the key is lost or found by someone else, or maybe someone can break the lock. And most importantly, should we just rely on the lock, or we should remove fuses, we should remove the cables, or that means two domains: lockout, tagout, and isolation. And isolation is more effective than LOTO. Remember my words. Isolation is more effective than LOTO, because in isolation we disconnect. We disconnect the full system. That means more better safety. No chance of anyone to turn on the breaker, or so everything same as have advantages and disadvantages. Now, one more point is the double insulation. That means the live parts of the past that might become live under fault conditions cannot be easily touched. So double insulation is also helpful, but often achieved by having two layers of insulation. That means between live conductors and any external metal surface or external surfaces or non-conductive like plastic, especially we called class 2 equipment, and no need for earth protection. But this double insulation also have advantages and disadvantages. So can you just find out what are the advantages and disadvantages of double insulation? I'm opening this question in the chat box. Advantages and disadvantages of double insulation. Please, you can use your little bit more energy and try to find out advantages and disadvantages of double insulation. And let me know what's your understanding. Advantages and disadvantages of double insulation. So yes, that means more layers of protection. So you're right. That means we can avoid from any kind of electric shock or anything. There is a possibility of casing becoming live from the external side. And do you think the disadvantage is only the cost? Can you just little more find out a little more deeper, the disadvantages of double insulation? Guys, find out some more disadvantages of double insulation. Even though it's provide a good protection against electric shock or electrocution, and especially no impact from the external side. But yes, one way around there is a cost. But what other disadvantages are there? Because this topic was, in the headlines in BBC also in UK about electrical safety, and the key debate was what are the benefits or kind of advantages and disadvantages of double insulation, and why we have to go for this particular system always, why not some other alternatives. And especially, this double insulation, even I would say for our home appliances, especially our washing machines or cookers or the refrigerators, they must have double insulation, for better protection. And even we can interconnect the earthing process also in between. Because I hope you have some like vacuum cleaners or electrical drills even. Usually we use them in several terrible conditions, like like in summer season, even in cold season, so outside in construction especially. So we require double insulation, because it will definitely avoid from electrical shock. But I'm talking about what are the disadvantages of double insulation. Yes, guys, any other opinion, please? Like Mr. Yusuf mentioned, the cost is the disadvantage of the double insulation. It's more expensive. Even it's beneficial, but absolutely right, it's more expensive. But what other disadvantages? Because somehow you need to find, the information with the reference, like how OSHA is guiding about it, HSC UK or any other regulatory bodies. Whatever solution you're finding, it must be referred with some level of regulatory bodies, Let me repeat again, all the advantages and disadvantages you have to prove through OSHA regulations. And just for your information, I'm sharing one standard of OSHA for your further deep understanding in the WhatsApp group. It's 26 pages. And within that, you will get a scenario of grounding also on double insulation. Especially for conductors and connections we required. Okay, so I'm sharing this document because this is what is the challenge of this open book exam. Whatever we are talking about, we are writing about, must be linked with some of the standards. We have to quote that standards or references. And one of the study I'm sharing again from OSHA for just for electrical hazards, and how as per OSHA you can control them. It's like 74 pages are there. And it's not like you have to study everything within these days, but at least there must be some reference. Since it's an open book understanding, so it's not a problem. The problem is if you don't put the keyword and finding out the right set of information, or you don't have the browsing hobby, then it's a problem here. So we truly have to create that browsing and searching hobby. And one document I'm sharing, just for electrical safety in the workplace, again, as per OSHA, because right now we are just studying Nebosh theories, that means the UK theories. But I'm sharing USA based because in Saudi Arabia, we have a strong alliance with USA, and mostly we are respecting USA based regulations like from OSHA, from API, American Petroleum Institute, even ASTM, or even some other regulatory bodies, just because mostly we have American brands operating in Saudi Arabia. And this electrical hazards or electrical safety in the workplace is 63 pages. And whenever you want to learn more deeper about electrical safety as per OSHA, you have that study, kind of a guidance. And one study I'm just sharing, only how to control electrical hazards, like as per OSHA 3075, only controlling electrical hazards. So now I have changed a little bit the pattern. Instead of sharing only the link, I'm trying to download these studies and sharing in the WhatsApp group, so that whenever you get time anywhere, even by drinking your coffee or having some, some time for yourself. So just as a hobby, you can open and see what OSHA is guiding about controlling electrical hazards. It's 71 pages. And if you will put any answer or any kind of material you're going to use from these studies or from these books, then make sure you give the reference. Like OSHA 3075 is all about controlling electrical hazards. Now let's talk about RCDs, the residual current device, specifically designed to protect human life. That means the RCD is specifically designed just to protect human life. Constantly compare current in life and neutral as well. Sensitive to small current imbalance, like i.e. leak to earth, very sensitive, like 30 milliampere, and very fast in 40 millisecond as well. Now, can be used as part of a plug, as standalone device as well, hardwired into the distribution system. And yes, we need to find out some of the advantages and disadvantages. And I'm opening this question in the chat box, the advantages and disadvantages of RCDs. RCDs. Advantages and disadvantages of RCDs, but I'm requesting again, I need, the standard reference actually, because the general theories from Google, from here and there, you can get plenty of freehand answers, might be written from me, might be uploaded from you. So, but we need authentic answers with authentic, globally acceptable reference as well. Advantages and disadvantages of RCD, residual current device. Like in the previous slides you have studied, it will surely reduce the risk of electric shock. It's a greatest advantage, especially for 220 voltage. And on the other side, if we are avoiding electric shock, means we are saving the life, or kind of avoiding the risk of death or injury, because of this electric shock. No harm, you can use any authentic source, but what I always guide to the trainees, find out the references or the sources which are globally respected and acceptable. I'm waiting for your answer, guys. Even in the presentation they mentioned some of the advantages already. That is protect human life, and even sensitive to small current imbalance. That means immediately we will be kept safe because of RCDs. No no electric shock, or that means no chance of death or injuries. But what are the disadvantages? Advantages are already almost mentioned there. So you can focus only disadvantages of Rcds if you believe there is any disadvantage. Because everything have limitations or disadvantages, because this kind of RCDs, the major issue is it can't actually remove all risk of electric shock or even fire. That means that residual energy will be there. We call remained energy. It will not remove or eliminate the all possibilities of electric shock or fire. And also RCD alone would be unable to detect, some kind of overloaded conditions, or face-to-face short circuits in. So you can find some of the information in the electrical safety and controlling hazards and different theories I shared in the WhatsApp group. And you'll find some information related to RCDs from there as well. Now let's talk about reduced and low voltage systems. As voltage is reduced, so the shock current is reduced also. So less the voltage, less would be the shock current. So UK voltage 230 volt struck down to 110 for portable tools. That means for portable in UK, they believe 110 must be there. And 50 volts equipment like SCLV. So 50 volts equipment also they produce, but normally in Saudi Arabia, especially in Saudi Aramco, they made it standardized like 220. And just for their distancing, a lot of 110 volt portable tools, they are not working, especially in the extension boards, because mostly are designed for 220. Or some issues with the portable equipment itself, they're designed for 110, but on the other side you are using 220. So this kind of some practical issues at the side still are there. Now there is another group exercise. What factors do you think should be considered when selecting suitable electrical equipment for use on a construction site? Consider you are a procurement manager and you are going to buy some electrical equipments. What things you're going to consider, before you buy it? What factor do you think should be considered when selecting suitable electrical equipment for use on a construction site? So I'm opening this question in the chat box. Factors in buying suitable electrical equipment. What factors you're going to consider? Okay, so must be certified or enlisted with the UL, underrated laboratories, or FM or CE or NC. That means the quality must be validated through some European international standards. And yes, accredited laboratories are there, gonna validate your quality through your technical file and understanding, and must be approved one. Now we have another topic, and yes, easy to be used as well. You're absolutely right. It's not like buying highly complicated equipment and our employees are in trouble, and more complicated electrical equipment mean more chances of accident if our employees are not well trained, for each step. And sometimes it's really hard to understand operating manual of some of the equipments. Now, control measures when selecting portable electrical equipment on construction site. First of all, make sure use battery powered, reduce or low voltage equipment. And also we're gonna make sure they have Rcds, locate cable carefully and use double insulated equipment, carry out pre-use checks, train operators in correct use and avoid using in wet conditions, and implement routine visual inspection and testing as well. No, it's the same one. Even in the first IG1 4 elements, we have discussed one of the term we call competence. What do you mean by the term competence? Can you just refresh your knowledge here? The meaning of competence, the term competence. How you can claim someone that he is competent? Because even though Nebosh have mentioned few of the factors, like if he received the correct training for the job and he can demonstrate it. Okay, mashallah. So that is, I'm sure, your internal policy also. Somebody has the skill to do the job. Okay. Yes, Mr. AB, you're also right. Anything else, please? So in short, any person who is knowledgeable, having an appropriate required skill set for that particular process or equipment or material, or and even the performance you can measure, you can verify, and he can perform well. And most importantly, if his experienced one is kind of a diamond edge, I would say. And yes, he must have some leadership and potential within. So 6 important factors, but in Nebosh, they just mention knowledge, skills, experience, and at some level, he can perform, or kind of certificates. But overall, it's a combination of 6 important factors, like the person must be knowledgeable, skillful, a best performer, experienced, and most importantly, he must be having some leadership skills for that particular process. And potential is critically imperative, because sometimes you have everything, but you don't have the potential to execute your knowledge or your skills or even perform as per your experience. So bear in mind the potential is critically important, because I personally have noticed also being interview, especially in the interview panel, sitting and hiring people. I personally noted, some people, they are knowledgeable, even they have right set of skills, but unfortunately they're missing some level of potential to execute, because everyone is psychologically is different. Someone is bold enough, confident enough, and he knows how to perform an activity with full of focus and perform the way he was performing in the previous job maybe. But some people, they are hesitant, they still have shyness, they still have kind of a possibility of terrible human errors, and they still take some unnecessary pressures from the leadership, and might be got confused. So your potential, the solid potential, along with all those factors, is highly important, because otherwise still it's a failure. Like after this training, you are going to be fully knowledgeable, mashallah. And if you execute that knowledge, that means but even you already have experience, because it's all scenario based understanding. Now, after this training, if someone is saying, okay, can you just show up can you make one of our area as a role model and improve, the safety standards of that area, even though our system is excellent, but still the biggest room in the world is the room for further improvement. And still, since you have joined NEBOSH IGC training for 10 days, so can you just bring some more better practical improvements and make one area as a role model, maybe one process, maybe one department, maybe any area of your organization, could be a chemical storage area, could be a warehouse, or any process, of your, and the management says, okay, bring something extraordinary and show, and make that area a strong role model, because since you have attended 10 days training, so now we really want to see the effectiveness, how are you gonna give some some kind of better value addition to the company processes, or to optimize some of the processes by implementing some HSE theories, in line with OSHA, in line with some other like ILO, in line with WHO, in line with ISO, International Standardization Organization, or maybe incorporating some other standards from CDC, from Ministry of Health, from Civil Defense, from Baladia, from PME, from EPD of Saudi Aramco, or maybe RC, some environmental standards, or HSE standards, So you bring all together and just focusing on that area only, and trying to make that area a solid role model. And then you lead by example, and then the same model must be benchmarked and implement in all other areas of the company. So we don't directly, approach every area of the company. We just decide, okay, this is the focused area. I'm going to implement all my knowledge, experience, and skills, and whatever I learned during the training even. So I apply all the knowledge here, and will make this area a handsome kind of role model. And then, we'll get some feedback from the top management, from your safety directors even. And if they appreciate, they will benchmark the same model and implement in other areas. And this is how you also build your brand as a safety professional, as a safety leader, instead of focusing in every area. So much better is chop up the elephant, like I mentioned many times. So break out the plan and see how you will be executing, inshallah. Otherwise, if you don't bring some more improvements, even especially after this training, or even especially after achieving, inshallah, IG1 and IG2 with good marks, and later on you don't bring, God forbid, any kind of solid improvements within your company, then definitely the value addition is missed, or the effectiveness of that training is not shown actually from your side. I hope. And some companies, they have competency enhancement chart every like after the training, they will reevaluate and enhance your competency chart, like for each employee, especially HR, human resources department, they have competency metrics for almost all the employees. So your competence levels should go up, even though you are getting third-party training, and might be they can have some practical, some kind of experience from your side, and see how you can bring some better value addition to their processes, to their departments, or even to any nook and corner of your company. So you have to prove. If you can't prove your competence level, the enhancement of the chart or the graph will go down, or maybe sustain at the same point. And if it is sustained on the same point, God forbid, then again, don't expect any kind of promotions or more higher position, even within your same company, or maybe from the market. I noticed many of my students, they just attended maybe 5 days OSHA training, and now they are the safety manager. What they have? Only OSHA training, no NEBOSH, no NEBOSH ID, no CSP, no ASP, because they made a role model to certain areas and prove in front of the management, look, I'm the right person for the right job. I'm capable to add value to your company operations. Absenteeism will go down, the productivity will go up, quality will be more improved into that area, less will be the injuries, maybe zero accident, into that area which you targeted and you made role model, and then, throughout your career within the same company, no accident into that area. That is a clear evidence you are an excellent safety leader, mashallah. So that should be our. So this term competence looks like one word, but it's like an ocean. And ultimately, we attend several trainings, we learn day to day because we want to be competent. Now, as per Nebosh, the competent person means, especially for electrical safety, he must be knowledgeable, relevant to electricity, like he understands all the hazards, he knows how to control, he knows what PP is required, and he has some technical know-how before he approach, and even he follow the work permit system before he even start thinking to perform his job. He get permissions, he make sure all the safety regulations are kind of, even the procedures are being followed, especially for lockout, tagout, or isolation. And he must be experienced of electrical work, understanding of the system and understanding of hazards and precautions, and ability to recognize whether safe to continue work, yes or no. So that means the common sense as well. Now, safe use of safe systems of work is kind of a work that whenever possible, work on a near live electrical equipment. That means only under exceptional circumstances and if controlled tightly as well. Now, working on or near live electrical systems, first of all, no live working unless no alternative. If essential safe system of work is include like permit to work, competent persons, insulating PPs such as boots and guntles, even insulated tools and equipment, and designated work areas. Isolation, we discussed already the lockup target, but isolation is written more deeper, usually requires the breaking of the circuit, physical securing of the break in the circuit, and some form of label or tag. Now, how are we going to prevent buried cable strikes? May be struck during excavation and can result in arcing, shock, burn, and fire. And several incidents are happening still. If you go back and have some study, have some accident analysis only for underground cables, you will find plenty of case studies in. A lot of incidents are still happening. That means maybe they didn't use the drawings, maybe pre-excavation checklist was not used, maybe no cable detectors, maybe no right person for the right job, or no metal detectors. I hope you got the point. So it's before, during, and after, whatever we are performing, we have to understand the safety regulations of all three domains of any process, like before, during, and after. Now, precautions like check plans, detection equipment like CAT scanner, and also exposed by hand digging, identify and label as well. This is how we can prevent buried cable strikes. And if you are working near overhead power lines, even though I shared some, some kind of regulations from OSHA in the WhatsApp group, usually uninsulated control measures, we need to arrange isolation or cover sleeves, safe systems of work and permit to work. Barriers, we need signs, goalposts, also banksman like signaler, and most importantly, the non-conductive equipment. I repeat again, the non-conductive equipment, not the conductor, to bring into that area. Now I'm opening one question in the chat box. What action should be taken on finding a person suspected to have suffered an electric shock? Even this question you can ask to your first aiders also. Like, what action should be taken on finding a person suspected to have suffered an electric shock? Like, if someone have electric shock, how your first aiders will respond to it? How are they going to recognize and suspect that the person is affected because of electric shock? So I'm opening this question in the chat box. So I appreciate if you can respond to it. Okay, so how to find electric shock person? So how would you identify that the person had electric shock? Mostly this is the major responsibility of our first aid team, our emergency responders. So then they can respond accordingly. Follow ERP. Excellent AV. Sometimes I say gravity is the best. Instead of 40 words, mention only 4. So they should highlight, the crux or the meaning of 40 words. So I like your way, AV, mashallah. Simple. ERP. You need to follow ERP, but that ERP should cover that element. What is the element? How to find a person suspected to have suffered an electric shock. This particular area must be part of our emergency response plan. Then it's okay. We can follow ERP. Yes, absolutely. Yes, absolutely. That is the purpose of ERP. Now, these are some of the emergency procedures following an electrical incident. First of all, don't touch the casualty, call for help, an ambulance, turn off power supply. And if can't switch off power, isolate casualty from the supply and check for breathing, recovery position. If breathing, start CPR. If not breathing, but don't do it if you're not trained for. Even though as per American, Health Association or kind of, they have guided 2 steps almost in all 50 states of America. How to call 911, number 1. And secondly, how to push harder and faster in the middle of the chest. I repeat again, they have guided 2 steps how to call 911. If somebody they found became unconscious or suddenly fell down. So as a general public, still you are authorized, if you are fully confident trained for like how to call 911, sharing information, what happened, what is the situation, and even location, they'll trace, the system will trace the location the moment you will call 911, and then immediately they'll start the journey. On the other side, your second step is push harder and faster in the middle of the chest. Even though they are not the first aiders, like no third-party trainings, no certification, but still they know 2 steps how to call 911 and the most important, how to interlock the fingers and put harder and faster in the middle of the chest. And American Heart Association always playing a vital role, and through this they are saving a lot of lives. But if you are a first aider, then all 7 steps or 8 steps you need to follow for CPR. Like even one step, I would suggest, even that should also be a suppressor, how to interlock our fingers. Where we have to put our palm, how to interlock our elbows while we are pushing. And this is another step also to understand how much we have to push. Like up to 2 inch, more than 2 inch means even you can break the ribs actually. And most importantly, how you will tilt back and make sure the windpipe is clean. You will follow cap process, or you'll follow ABC, or you'll follow CAB. Which method like you're gonna use? Like clearing the airways, giving breathing, and then compressions. And you'll keep continue. And what would be the circle of that compressions? Like how many times you need to push? Like 30 times and 2 breathing, and keep this cycle on and on until the ambulance arrived or the medical help is there. And I call the first aiders as the first doctor as well, but not the final one to decide the person is no more. So they just need to keep that activity until, because every second is critical. So they have to keep trying, and later on the medical help is there. So if there is a burn, so they have to treat the burn, treat for physiological shock, or ensure medical help is obtained. There must be some inspection and maintenance strategies, especially for fixed wiring systems and portable appliance testing, combined inspection and testing. And here, I suggest to the companies, hire the third party, so you would have a solid evidence that your electrical systems are still credible, active, and have no issues. And there isn't any chance of, shock circuit, or any chance of major fire incidents, to be happen, God forbid, because your complete electrical system is verified, validated from the third party. Same like we have third party inspection for crane, for forklift, for lifting gears, even for compressed gas cylinders, even for several things, even for our fire safety system. Also, we have third party companies to ensure that the system is still working in a good condition. Otherwise, internal inspection is critically important, like combined inspection and testing. Now, consider, it's a group exercise. Consider the use of portable electrical tools at home or at working, like iron, sand, or drill. Discuss how the tools, leads, and plugs become damaged. What you would look for if you were checking that they are safe to use. How are you going to decide that your all plugs are still okay enough and not damaged? It's quite simple, but surely you can respond in the chat box. How to inspect your plugs, at home, plug of anything. Forget about iron or sand or drill. Any plug. How to inspect the plugs at your job or even at home. And should we have separate inspection checklist only for the plugs, only for the electric panels, only for the generators, only for the compressors, only for the kind of switches? What should we do actually? Or a combined electrical inspection checklist must be there, kind of a safety inspection checklist, and covering electrical systems as a portion or as a part of that checklist. But how are you going to inspect plugs and decide either still they are okay or not okay? Take your time, guys, but let me see your response, please. How are you going to check? Look at the picture, look at here. Is it okay? All steps, overall the condition of the internal side. And are you going to open every plug to check the internal condition, or you will just have visual inspection from outside? And if you decide, okay, I'll open every plug and then we'll see, or you will just see the suspected one where you have some doubt, oh, this plug might be damaged internally, or even the plug itself gonna speak up, because if it is not working, or the, like iron plug is not working, means something is defaulted inside, right? But anyhow, guys, these are the user checks, like Mr. Yes, you're absolutely right. We know the latest technologies and a lot of solutions are there. Okay. So before buying new house, I will check all. Or trust me, AB, better to construct your new home, new house, inshallah, under your leadership. So no one can play. If you were rely on some contractors, you never know how they'll be playing and where they'll be playing. Maybe the samples they're gonna show excellent, but on the other side, yes, of course, all the steps you mentioned, Mr. Muhammad Al Gamdi, mashallah. But for user check, make sure the body of the plug intact and secure. Outer flex sheet covers all inner wires. Plug and appliance cable clamped tight. Flex fully insulated. No splits or kinks are there. Body of appliance intact and no damage to casing of equipment. No burns, scorch marks, or not soiled or wet. So just increase your vocabulary, even though we have understanding, but no harm to have few more words, to bear in our mind. Even though it's an open book, but ultimately at site, every time we can't open our book and see what we have to do. So some of important factors for electrical systems, for chemical handling, for equipment and tools, for heavy equipments, for different kind of safe system of work, for different procedures, different kind of critical safety rules and regulations must be remembered, so that we can support people on site without books actually. Otherwise, every time, how come we can open books at site? Someone is asking what should be the distance between excavation and crane, or distance from the live cable, and we can't say, okay, I will come later with a book to tell you. So some of the things, some of the data you have to store here. It's important, as a safety leader. Now, formal visual inspection, use checks plug, remove plug cover and check, fuse connections are secure, terminals are secure, and no sign of internal damage. But it must be done by, again, a competent person. How are we going to do combined inspection and testing? We have visual inspection may fail to detect because you can't find out the defective or deterioration of insulation and pathway. What we should do, inspection and test. When suspect equipment is defective, after repair and modification and at appropriate intervals, and it must be done by the competent person. And what should be the frequency of inspection and testing? We have to follow, first of all, the legal standards and codes of practice. Now here, I'm opening a short research, of inspection and testing codes or standards related to electrical systems. Okay. Standards or codes for inspection and testing standards or codes for electrical systems. Let's find the references, and that is the reason I like OB, the new pattern, from Nebosh, because now we are talking more practically instead of just theory. Even though there are malpractice, people are misusing, that is their unethical approach, finding someone, resolving their exam and getting the piece of paper. But on the other side, no practical insights, no practical experience, and then getting embarrassed and being flopped, I would say, and terribly failed, especially at the site, because you are going to deal the bonanza of expert professional, highly expert professionals, and they will judge immediately, either you just got a piece of paper or you have some real sense of knowledge. So that's why let's try to find inspection and testing standards or codes of electrical systems. Let me find a PDF, some kind of downloadable, so I will share with all of you in the group. And if you find, please, you can also share in the group. You can refer even Royal Commission, some of the inspection and testing codes and standards for electrical systems. Excellent, Mr. Muhammad Al Ghamdi, but which one is more relevant to inspections and testing? Can we find from OSHA also? or even NFPA. I'm sharing one, but it is more relevant to, for home-based. 11 pages conducting residential electrical inspections. So it will surely give you some idea. And a lot of references are given at the end also. I shared already in the WhatsApp group. Same way, we can find out something from OSHA as well. So I hope you got the idea. We just need to find out the relevant, because even though we are studying this material, so we can give a reference RCC material or NEBOSH IG1 and NEBOSH IGC2 books, because here also something mentioned, frequency of inspection and testing, like legal standards and codes of practice. And typically we can get from SASO also for Saudi Arabia. Surely they would have some standards for inspection and testing. The type of equipment, whether or it's not handheld, and manufacturer recommendations, initial integrity and soundness of the equipment. And even the moment we buy some electrical equipments or plugs or anything, there are also written, these are made as per which international code or standard. That could also be helping and finding out inspection criteria as well. Initial integrity and soundness of the equipment, age of the equipment, working environment, frequency and duration of use, foreseeable abuse of the equipment, and effects of any modification or repairs, analysis of previous maintenance records, all are important here. So these are the factors to determine the frequency, Now, what are the advantages and limitations of PAT? Can you just mention in the chat box what are the advantages and limitations of PAT? And do you have any idea what is PAT stands for? And this PAT tool is not only for the HSC professionals, even the quality team members or the department leaders must also be familiar what is PAT tool and how we're gonna use it, because it will give a detailed process analysis. That's why it's called process analytical technology. Definitely it will give us a clear picture of how this equipment or plug is all the way is good enough for in terms of quality, in terms of the durability, complete analysis. And can we find any reference from OSHA for this PAT or UK HSE? Can you find any advantages and disadvantages? Because through the PAT test, or kind of a PAT testing, of course, it will test and reduce the likelihood of appliance catching fire, or even it will ensure electrical appliances to provide kind of, you provide to the especially industries of the home based, and also to reduce the chances of a fire in the workplace as well. So that means the regular PAT test can save our money, and in the long term a lot of benefits. So proactively is kind of a due diligence process. Before something happens, you are evaluating the possibilities and accordingly taking some actions. Because it's a system of designing and analyzing, and controlling pharmaceutical manufacturing processes through measurements of critical quality and performance attributes of raw and process material to ensure final product quality. So that's why I'm telling, it's not like only HSC leaders, even the quality leadership must also be using this tool, to make sure nothing will go wrong, and proactively they are evaluating. So these are the some of the portable appliance testing like PAT. That means the detailed analytical approach. Some defaults you can see through visibility, that means to your eye. Complete analysis you'll get, and early removal, repair of unsafe equipment, and demonstrate legal compliance and identify trends or patterns of faults. But problem The limitations are provides proof of safety at one moment in time only, does not ensure safe use or prevent misuse, or items may be missed and then remain untested. So can't be applied to all equipment like computers, So any sort of portable appliances testing or kind of pad, or we call it process analytical technology as well, because ultimately we are verifying that this particular equipment or tool is fit to the purpose and have no issues. In advance, we are checking. Okay, guys, so that was all about the element number 11, the last element of IG2. But in this element, so far we have discussed, the electrical principles, especially the volt, current, resistance, and relationship between them. And most importantly, the key part from number 5 element to 11, we identified several hazards, especially like electric shock, burns, direct or indirect, fire and explosion, arcing, and secondary effects. And we discuss about effects of electric shock and how several factors can influence the severity of injury. And also we discuss the reasons why portable electrical equipment is often involved in electrical accident, and also why PAC tool is important to follow it. Now, various protective systems we shared about for electrical equipment. We also outlined the importance of restricting work on electrical systems, especially only competent persons would be allowed. A safe system of work also we discussed, especially to control high risk associated with work, especially near electrical systems, and also described an emergency procedure to put in place if a person is injured in an electrical incident, and importance of user checks, formal visual inspection, combined inspection and testing, and we also discussed the PAD tool for inspection and testing. Now this is all about IG2, but just tomorrow inshallah we will just have exam preparation for IG1 and IG2. And even though I have sent you one guide to your WhatsApp group, but how to follow this guide and apply, we have one scenario and some question and answers already shared. So we will see how that guidelines practically implemented into our exam, patterns actually as per Nebosh is expecting. Okay, guys, just in a quick nutshell, we have some training plan for 2021, and we are delivering some sessions, especially on emotional intelligence, anger management, best customer service. So all are basically soft skills training required. It's not like only you're going to learn about safety. Imagine if you're not emotionally intelligent, hard to be successful in any profession. Same way, if you have poor anger management skills, or ineffective team building, or no effective communication, or no negotiation skills, or you don't have any train the trainer programs, or you don't attend any kind of stress management, or effective hiring skills, or meeting management, or effective admin support, or effective report writing. So you can still contact with us if you need any of such trainings, for your throughout your business group. Even though I know mostly trainers we are calling from Australia, Canada, and US and some other, but now we are referring the local talent, and many of our Saudi friends, they are the best trainers, mashallah, like in Arabic and English. And let me share with you, we were looking for one safety trainer, and the moment we publish, I personally received 593 CVs for the post of safety trainer. And the good news is 90% Saudis were there. This is a strong indicator that you guys are fully productive, mashallah, to lead your country and up to your 2030 vision. Everything will be under control, under your strong leadership, inshallah. So just let us know whenever you need us for any support. You can share your event training plan with us, and might be we can choose some topics and support your training plan accordingly. Thank you very much. So nice of you. Have a great day, and tomorrow, inshallah, same time, I'll catch you at 10 o'clock. Thank you very much. And any question, any confusion, you can share in the WhatsApp group or personally on my WhatsApp number. Feel free to ask anything. Thank you very much. Okay. See you tomorrow, inshallah.